Okay, we come to the final talk before lunch. It's hijacking mobile data connections 2.0. Roberto Picarillo, Roberto Garcia.
Okay.
I'm looking forward to the talk.
Okay, thank you. Hello to everybody. I'm Roberto Picarillo from Mobile Security Lab. Thanks for being here today. And thanks for Alberto Caporro, who is here today, and Cristoforo Mune, who is not here today. I'm going to present our work on hijacking mobile data connection version 2 with automated data improvement. So, a small summary. The difference between the first version presented in the last Black Hat and the second version. Next, a few words on provisioning process. Next, a warp architecture primer concept. Next, we will try to forge a provisioning message. After that, my colleague Roberto will continue with the provisioning process and the security issues noticed in this process. After that, we will propose an attack scenario, and we will show how it's possible to exploit these security issues noticed previously. We will end our presentation with with a real demonstration of our attack scenario. So, in the first work version 1, we did the remote configuration of devices by SMS using HOMA provisioning protocol. We did the DNS subverting on certain mobile devices, a DNSFX server in order to respond the client's request. And next, we did a transparent proxy using Apache, with mod security in order to perform traffic inspection. Today, we would like to take a few extra steps on previous work in automated attacks and sneaked attacks with a clever security mechanism. We will build a general malicious configuration valid for most devices, and we will deal with SSL connection. So, why is the provisioning process necessary? Because mobile equipment must be configured to interoperate with mobile infrastructure and services. According to standard documentation, the provisioning is the process by which our client is configured with a minimum user interaction. And this process is performed using warp architecture capabilities, and normally it's used by mobile operator. So, some words on warp architecture. The first sentence is standard documentation, and there are a lot of applications that use warp architecture, for example, MMS application or web browsing, as in our case, a provisioning process, and social network application such as Facebook, Twitter, and other applications such as Skype, MSN, and so on. WAP architecture provides a communication protocol framework. In this framework, there are two kinds of communication models. The first one is the pool model, in which the clients send requests to the server, and then the server sends data to the client. In the second one, push model, the server sends data to the client without client's request. The second one is important in a mobile environment because it's used to send unsolicited data from the server to the client. So, this is a picture of protocol framework. It's divided in layers. The free application, session, transfer, transport, bearer. Now we will try to forge a provisioning message according to this protocol framework. And we will see which of these layers is involved in this process. So, The first part of provisioning message is a provisioning document in the application layer, and a provisioning document provides parameters related to, for example, new network access point, for example, application-specific configuration. Is used from mobile operator, for example, to provide the configuration to new customer, or for example, to reconfigure misconfigured mobile phones, or for example, to enable new services. The important thing is that each provisioning document is encoded always in WB XML document. This is an example of a translation from XML document in XML language in WB XML encoding. The first part of the slide showed a new configuration for the new network access point, in this case with name DeepSec, with, for example, NAP address apn.deepsec.com. For bearer, GSM, GPRS. In the second part, there is the WB XML encoding of XML document. This encoding is necessary because the communication is more efficient. The next layer involved in this process is the session service with W-Session protocol that provides connection services push. When we want to send the provisioning message, we have to specify the media type application/wendy.web.connectivity WB XML. In this header, we can add the security information, for example, sec parameter to specify security mechanism, or for example, security mechanism related information. Some words on secure objectives. Message authentication protects from accepting malicious messages from untrusted sources, and messages with no authentication may be discarded. Security mechanisms are based on HMAC calculation in order to preserve sender authentication and document integrity. Security mechanism used is typically based on shared secret. There are several kinds of shared secret. For example, the first one is a user PIN used in the last presentation presented in the Black Hat. This is a numeric PIN code chosen by the sender. In the second case, network PIN that will be used today is the IMSI Information International Mobile Subscriber Identity. And the last one is user network PIN, an hybrid approach between user PIN and network PIN. This is a flowchart of HMAC calculation. Takes two parameters. The first one is the key, in this case, network PIN represented by IMSI. And the second parameter will be the provisioning document encoded in WB XML. A few words on IMSI. It's an international mobile subscriber identity and uniquely identifies a mobile user. Is permanently stored in the SIM card, and HLR is a mobile operator database that stores the page MSISDN IMSI, is associated with a MSISDN, and it's used during the subscriber authentication procedure. But the important thing is that this information should be regarded as a confidential piece of information. IMSI consists of 15 digits. The first 3 digits is a mobile country code, uniquely identifies the home country of the mobile subscriber. The next 2 digits mobile network code is of 3 digits or 2 digits, depending on we are in USA, for example, with 3 digits, or we are in Europe with 2 digits. and identifies the public land mobile network of a mobile subscriber. The remaining digits is the mobile subscriber identification number that identifies the mobile user to the public land mobile network. Next, we will see how it's possible to use this information in the second part of the presentation. As I have said before, IMSI should be a confidential information, but there are a lot of websites that offer very cheap MSI lookup services. In our case, we have spent 2 cents for each MSI lookup. This is an example. We provide the MSISDN, and services on web retrieve the IMSI via mail or via HTTP post. But before we can use this information as a security mechanism in order to forge a provisioning message for using each MAC calculation, we have to manipulate the IMSI. We add the control nibble 9 digits in front of IMSI, and we will have a 16 digits. After that, we can select these digits in pairs of 2 digits. And we can use the semi-octet representation, inverting the digits inside each pairs from IMSI. After that, we are ready to use new IMSI information as HMAC calculation. Is the first parameter. The second one is the WBXML provisioning document built before. Some words on WSP primitive push is used for sending unsolicited information from the server to the client. There's some details on this payload. For example, this is an ID of payload. Next information is O6, a PDU type push messages. QF is the header length of payload. And then we have a B6 is a content type application / WAN WAP connectivity WBXML. This information will be used by the mobile phone, the receiver mobile phone, in order to understand that this is a provisioning message. 9118 is the SEC parameter with networking security mechanism. In this case, is an IMSI retrieved by the services on web. Next, we have the MAC parameter, and the next 40 bytes is our MAC calculation. The transfer services is not used in this process, and then we skip it. Another layer is transport services with wireless datagram protocol. And WDP support is mandatory on any web-compatible handset and can be mapped on different bearer. WDP over GSM SMS is used to send the message. This is the first part of our provisioning message, the WDP header, following by WSP header, and the last part is a WBXML payload. WDP over GSM SMS header is defined using UDH headers, and this header contains information for example, port addressing and concatenated short messages. This is an example. In this case, O5 represents the application porting addressing scheme. OB84 is destination port 2948 for WAP push services. OO is a ID for concatenated SMS. O2 is the total number of SMS, and the last information is 1, ED of current SMS. The last layer involved in this process is the bearer network on GSM SMS, and the support binary data transfer with an uncompressed 8-bit encoding scheme. A concatenated SMS is needed to send a payload larger than 140 bytes. Performed tests suggest that no restriction are imposed on sending SMS encapsulated provisioning messages. We have completed our construction, composed by 4 parts. This is a GSM SMS header. For example, we have a SMS submit with UDH header 41, the receiver phone number length, the 91 is international format of our number of a mobile phone. This is the number, the encoding F5 to specify the binary encoding, and UDL is the length of our provisioning message. How we will send this, the SMS? It's very simple to send this forged provisioning message by mobile phone attached to a PC. But in this case, we have 2 problems. The first one is too expensive when a number of SMS increases. And the second one is hard to hide the sender's identity. But services offered on web allow us to solve both problems. This is an example how we can send the provisioning message using the services of web. In this case, we can specify the SMS sender, the phone number for the mobile phone. We can select the WSP header, WBXML payload, and specify as SMS data field. After that, we can specify the UDH header, the binary encoding, and now we are ready to send this message. So a small summary of our construction. The provisioning document can be easily created. WSP header is used in order to use network pin security mechanism with IMSI in order to perform the HMAC calculation. Next, we have the WDP support is mandatory on any WAP-compatible handset. And finally, SMS with provisioning document are typically unfiltered. Now, this is a tool that we use in order to send our provisioning message. We can select the web option for in order to send the provisioning message through the web. We specify the auto-select configuration in order to select the correct configuration for mobile operator. We select the list of victims number, authentication option, specify the IMSI lookup, the configuration that we want to send the mobile phone is the output. And next, this is an example after this configuration is installed on mobile phones. We have 2 mobile phones with a new network access point with DeepSec demo. Now I'll give you to Roberto that will continue the presentation.
Thank you. Hello, I am Roberto Gazzera from Mobile Security Lab. I'm going to show you the second part of the presentation that starts with the provisioning process. The provisioning process is the technical name of the auto configuration service. This is a service typically offered by most of mobile operators. For example, the service is available online. Have you ever seen something like this on your mobile operator site? And also, the service is performed automatically when you insert a SIM in a new handset or a handset not configured. The operator will send a message to you. Now, in the first version of this attack, we have used the user PIN provisioning in order to send the message to the victim. But and because as Roberto have explained before, the provisioning process, the provisioning framework provides two security mechanisms. And on these two security mechanisms, we have two provisioning processes. The first one is the user pin. The user pin is performed in 4 steps. First one, an info SMS carrying the user pin is sent to the user. In this message, the mobile operator advises the user of a new configuration message is arriving. After that, a provisioning document authenticated by the user pin is sent via SMS. But when the user opens the message, the user is requested to insert the correct user pin in order to install the configuration, and then the configuration is installed. So as you can see here, the user has to take note of the pin, and the user has to insert the pin. Now, in this version of this attack, we will use the network pin provisioning. The network pin provisioning can be performed in only 3 steps. First one, an info SMS is sent. This is only a generic message sent from the mobile operator. After that, a provisioning document authenticated by the network pin is sent via SMS, but this time, the user is not requested to insert the pin, but the new configuration is automatically installed. And there are some handsets where the configuration is installed, and after, the user is advised of the new configuration. So as you can see here, the user interaction is minimum. And this is the first main aspect of this new attack. Now, what is the attack objective? The attack objective is hijack mobile data connection by reconfiguring the network settings of a remote device. Okay, this can be performed in 3 steps. First one, identify the victim mobile operator. Because the new network settings, the new attacker network settings are strictly related to the mobile operator. Because for each mobile operator, there are some parameters that, if incorrect, the connection doesn't start. After that, we have to send the fake info SMS in order to impersonate a new mobile operator provisioning process. And finally, we send the malicious provisioning SMS in order to install the attacker configuration settings as the default. After that, the attack objective is reached. So now, let's focus on these steps. First one, finding the victim's mobile operator. Because we have a problem. We usually know only the target number of the victim. But with the number portability, it's not possible to find out the victim mobile operator only from the prefix of his number. But as Roberto explained before, we can use the IMSI lookup service in order to find the IMSI of the mobile number. And inside the IMSI, we have the mobile country code and mobile network code that together, with these two values, we can uniquely identify the mobile operator, and this way we can retrieve the network settings everywhere. The settings are available online, or you can call the customer care. However, the settings are very easy to find. Second step, the info SMS. Usually, a user trusts the message relying mostly on visual information. In details, the mobile operator service number. This is a number usually used by the mobile operator for sending information messages to his customers, and the mobile operator that advises the user of a new configuration message is arriving. But as we know, the message could be easily spoofed, and for a customer, it's impossible to figure out if the message is real or spoofed. Final step, the malicious provisioning SMS. First of all, the provisioning SMS is not typically filtered. And during all of our tests, all the provisioning messages sent have been always correctly received. Then we have another issue, because when a message is received, the user interface displays little and confusing information. For example, the message source may be hidden or reported incorrectly. In the first image, the sender is not shown to the user. In the second example, the sender is a generic sender. And also, few technical details on provisioning content are shown for the user. So when you receive this message and you want to accept the message, you can see the new configuration, the new settings of this configuration. But oops, we can have a problem. The sender number, because there are several handsets that can show you the sender of this message. It could be a problem, but as we have seen before, we can perform the provisioning SMS spoofing. So sending a binary SMS via web offers another interesting feature, the sender. So now we are also able to spoof the sender of the message. And for a victim, it's really hard to figure out if the new configuration is sent from the mobile operator or not. Now, we are just one step away, just one step away from the attack objective. That is to force all data connections to use the new malicious configuration. So when a message is received by the handset, there are several possibilities, depending on the handsets. First possibility, the new configuration is automatically installed as the default, and this is the perfect condition for an attacker. And also, when the message is received, the user is asked at installation time if the configuration has to be installed as a default, and it's also a good situation for an attacker. But finally, the user is asked at each connection time which configuration should be used for the connection. And this is the worst condition of an attacker. And the same in some cases, and mainly for customized handset by mobile operator, it may not be possible to change the default configuration. But for the other handset customized by mobile operator, that when receiving the message, the default configuration is overwritten and impossible to remove. If a user wants to remove the new configuration, the user has to refresh the handset. So let's summarize this attack. We start from the victim phone number. So first step, IMSI lookup in order to find the victim mobile operator network. And in this way, we can choose a correct provisioning message for the victim. As you can see, this step can be performed automatically. Second step, send a fake info SMS. This step 2 is part of an automated attack. And finally, send the attacker provisioning SMS with the new network settings. This is also a step that can be performed automatically. So, as we can see, we can repeat each of these steps automatically. And if we think at this attack as a function, we can iterate this function with a list of number in order to execute a massive and automated attack. So now we are able to reconfigure the victim handset, and let's move on hijacking. In the first version of the attack, we have chosen to reconfigure the victim handset with a new DNS server in order to perform a typical DNS subverting attack. But this kind of attack has several limitations. First one, DNS reconfiguration is not supported by several brands of mobile phone. And also, external DNS queries could be blocked by mobile operator. And finally, maybe the more important, that HTTPS traffic doesn't go to the evil proxy that we used in the first version of this attack. So now we have chosen to reconfigure the victim handset with the proxy. But as we know, a proxy configuration affects only HTTP and HTTPS traffic, but it bypasses DNS subverting limitation. Because, first of all, proxy settings are supported by any phone equipped with an OMA provisioning client. Because normally a proxy is used for the MMS delivering. And also, proxified HTTP traffic is hard to identify. And finally, the direct HTTPS communication passes unnoticed through the proxy using the connect method. But now, what is an HTTPS stripping attack? This attack is a man-in-the-middle attack presented by Moxie Spike at Black Hat TC 2009. This attack requires hijacking traffic, and now we are able to hijack traffic, and diverting it toward the SSL strip tool. This tool is a man-in-the-middle proxy that performs this action. HTTPS links in clear text traffic are downgraded to HTTP. For each downgraded link, the proxy channels the HTTP request to the victim, from the victim to the real HTTPS one, and then return the answer in HTTP. But now, let's consider the possible effects of this attack in the mobile world, because the attack could be even more effective in the mobile world. Because, first of all, few technical details are shown for encrypted connections, only really tiny padlocks. And also, small and uncomfortable keyboard translated to typing an HTTPS address, but what we usually do is to use a search engine for finding the address. And this is perfect because the traffic is in HTTP, and this is a perfect starting point for this kind of attack. And also, slow mobile connection, hide man-in-the-middle attack delays, and finally, SSL strip supports proxy chaining. Now, let's look. A user wants to visit www.paypal.com. So the mobile browser tries to connect to the site, but the site will answer with a 301 error code, requesting the victim browser to connect to the site using the HTTPS address. And then the client will connect to the site using HTTPS, so the encrypted connection. Now, let's take a look at how SSL strip can be used in our attack infrastructure. The user wants to visit the site. Our every proxy intercepts the request, forward the request to SSL strip, and SSL strip to the final site. After, when the final site will reply with a 301 error code, the SSL strip tool downgrade the new location links from HTTPS to HTTP and return the answer to the proxy and the proxy to the client. So this time, the browser will try to reconnect to the site using the HTTP encrypted channel, and SSL strip will start his job. This is an example of a provisioning document, proxy configuration provisioning document. In this provisioning document, there are three main parts. First one, used to define the proxy settings. The second one, used to force browser traffic through the evil proxy. And then the final one that allows it to work on many phones equipped with an OMA provisioning process. Our evil proxy is based on Apache and mod proxy. We use the SSL strip as remote proxy for only HTTP connection, because for HTTPS connection, we have enabled the connect method. And finally, we use mod security audit feature for acquiring the traffic in clear text. This is an example of what can be achieved with our attack infrastructure. And as you can see, the attacker is able to see what the victim is browsing. At the same time, we are able to gather the username and password of the user. So now we are going to perform a live demo.
Okay. Now, I'm going to send a provisioning message. In this case, we choose a web available online. We select automatic configuration using the IMSI information. We specify an info SMS that will be sent to the client. Specify a victim's list number.
Move the mouse.
Okay. And then we specify the authentication option, and then the IMSI lookup. So now we send this message.
But send is disappearing.
Aspetta un po'. No, la barra sotto.
We have changed the resolution. Moment. Perfect. Sorry.
Okay. The message is sent, first one, the info SMS. Okay. The first message is arrived.
And the second answer?
The first message advises the user that a configuration will be arrived on a mobile phone. The user then receives the provisioning message, but in this case, the sender is a service provider. The user will open the message, but this time the non-party message, okay. The content of a message advise that the configuration is for a new network access point. Now the user installed the new configuration as default, yes. Okay, now the configuration is installed. When the user browsing, all traffic will be passed between our infrastructure.
For example, now we are going to Google. We are connecting.
Shows the configuration before installed.
Pronto? And the configuration?
It's deep.
Okay. It's normal. Yes. Okay, I will try. Close the browser or reopen the browser. Okay. With this handset, we have a problem. We can try with the other one. No? We go to Google. We are connecting. And now we can start to see what the user is visiting. For example, I want to go to Twitter. I search for Twitter. We are intercepting the traffic. And the browser will see what the user is browsing. Then we go to Twitter. Sorry. We have the login page of Twitter, as you can see here. As you can see. One moment. Now we insert the username and password. Very long username and very long password. now we are going to the site. We have intercepted the password, the username and password, and now we are inside the Twitter space of the user. Okay. Now let's move on to the final consideration. So what can be achieved with this kind of attack? But what we can achieve the same things of a typical man-in-the-middle proxy attack. So we can monitor and perform monitoring and profiling user browsing, hijack browser session, steal application data, extrude mobile operator data, because now we are able to get from the network, from the operator, the network, analyze and input inside the network, and finally we are able to inject the data. Let's focus on the issue of this attack, because the attack does not rely on the exploitation of a single vulnerability, but it relies on the issues at the system level. And in details, lack of provisioning message filtering, and also user interface do not provide the sufficient level of details. And for the first version of this attack, mobile operator network allow use of external DNS servers. And after our presentation in Black Hat, today all the DNS servers are already possible to reach from inside the network. And finally, HTTP traffic inspection is really carried out. So the possible countermeasures can be, first of all, filter external provisioning messages on the network side. This is possibly the most effective, but it's really hard to perform. And also perform filtering on handset side, but it may be ineffective in case of sender spoofing. And also, another possible countermeasure is a user interface improvement in order to provide the proper detail level and warnings, but it may still be ineffective in case of message spoofing. And also deny access to external DNS server, and this could make the first version of the attack more difficult, but there are many operators that they use external DNS normally. And finally, perform content inspection on HTTP outgoing traffic. So thank you for all, and
Thanks.
Now we are ready for your question with the help of Alberto from English.
Okay, we have some minutes for questions. Other questions? We heard another SMS talk earlier today, so is it really necessary to use this XML stuff, or are there provisioning messages also that can be used without the IMSI authenticated stuff?
You can use the provisioning message with the user PIN, and but for the network PIN you have only choose the IMSI. Maybe this is the question is if we have to use only the IMSI.
Yeah.
Yes. No. For the network PIN is required only the user IMSI, because the IMSI initially was a value of the mobile operator only and only on the SIM. And so now
so the security model has changed.
There are growing the number of sites that offers this service.
Yeah. Okay.
Can you tell us a little bit more about this IMSI querying service? I guess it's not really legal, right? To provide this service.
The source code of the tool?
No, you query some service, right? Where you give them a phone number and ask them for the IMSI. The IMSI phone.
The name?
Yes. So, no, but I guess the service is not really legal, right?
Yes, they're legal. Yes, they're totally legal.
Okay.
A lot of web services online provides these services.
But if you try now on Google, IMSI lookup, you find there are minimum 2 sites in the first hits that you can use.
Do they provide the information globally, or is it for
globally.
just a certain
Globally.
countries?
Globally.
Okay. Thank
My question is similar. What service do you use to spoof the SMS source address? Because I've tried doing that for numbers in North America, and it's not been easy. I mean, I've worked with I've contacted a lot of bulk SMS providers, for example, to see what I can do to be able to control the originating address of text messages in North America, and I got nowhere. So what service are you using for sending your SMS? What service are you using for
the same that we have used, the same service that we used for the IMSI lookup, because the service is only they are sites that offer sending SMS via text label, or
Sure.
send SMS via binary, but binary using a base 64 encoding.
So yes, encoding the BCD with 8-bit compressed.
Okay,
We can
so
use both text for info message and a binary message for provisioning.
Right. I understand. I was just asking what service you're using, if there were any restrictions on what world zones you could do that in, because like I said, I've tried doing that in World Zone 1 and not found anyone who would do it.
The U.S. carriers block the
Okay, yeah.
Okay.
Any more questions? Yeah, then there is time to see you at lunch or outside. Thank you very much.
Thank you.
Thank you.